Hello, my name is Ryan. I'm a TF for this course, as you probably already know. And this is just going to be a short review of the two most commonly requested topics on the Google form I sent out, that being arrays and indexing and how to approach problems. Uh, yeah, Format, I'm just going to do a quick intro. Um, so I'm going to go over some vocab for arrays and indexing. I'm going to explain them a little bit more. We're going to go through some quick examples. I'll do one problem from the MATLAB exam review problems on arrays and indexing, and then I will switch over to how to approach problems, and we're going to go over two problems from the review problems, from the exam review problems. All right. So any line that starts with these two characters right here can be put directly into MATLAB, and you should get the same output as mine. Lines with this arrow that start with this arrow, that's just the output that you're going to receive from MATLAB. You can message me or any of the other TAs or TFs on Canvas with any questions. And if you're watching this recording, the link to this document should be available wherever you're watching it. So arrays and indexing, here's a little bit of vocab. Think of your array as just a list of values. An element is just an item or a value that is in that array. The index is just the position of a specific element in that array. If you find the word index confusing, you can try replacing it with the word position. A 2D array is just an array with two dimensions. The way I like to imagine it is as a spreadsheet. If you go to Excel or Google Sheets, you can open it up and you'll see it'll have both rows and columns. That's a good visual representation of what a 2D array is. So this is a very simple example, just to help you get the vocab a little bit better. I'd find an array EX1 there. 4, 5, and 6 are elements in the array. Index 1 is going to correspond to 3, because that's the first element in the array. Index 2 is going to correspond to 4. 3 is going to correspond to 5, et cetera, et cetera. Continuing with the analogy of an array as a list, to access a specific value in a list or to talk about a specific item in the list, you're going to need to say which item it is. So is the 5th item in this list, right? That's just an index. And of course, if you have a spreadsheet and you want to specify a specific cell of the spreadsheet, you're going to need both a row number and a column number. So you're going to need two numbers. Here's some common ways to create an array. You guys have definitely seen this a lot. One, you can just use brackets. 2, you can use colons. The thing to remember with colons is that it's always going to be start, step, end. So first number you set is going to be wherever you start. The second number is going to be your step size, and the third number is just going to be wherever you end. And if you don't specify a step size, MATLAB will do that for you. You can always use an already defined array to define a new array. So for example here, I defined an array T, and I then defined an array X, right, as sign of T. And now X is going to be an array with as many elements as T has. This is another way to define an array. So what I'm doing here is I'm taking the array T and then the end. So whatever the last index of T is, it's going to be that index plus 1, and that's going to be equal to 20. You can also load in data from a file. You guys have seen that in studios at homework, so I'm not really going to go over it here. Here's another quick example. This table is just a good way to visualize which element corresponds to which index. It's not really practical to write out a whole table every single time you're doing a problem, especially if you have big arrays. So I wouldn't necessarily recommend doing this every time you see it, but if you have simple arrays, it can serve as a nice visual indicator. The find command is just going to return the index of a specific element. So using this example, if I wanted to find the element 293, find is just going to search this array, and it's going to look. It's going to look, and then when it gets to 293, it's going to say, okay, that's the third item in the array, right? That corresponds to the third position, and it's going to return a value of 3. And that just gives you the last element in the array. And you can use it to index an array, right? It's always just going to be whatever the last element in the array is. Slicing is a method of accessing more than one element in an array. So using the previous example, what this says is find this array and get me values 2 through 4. Get me values that are in positions 2 through 4. So it's going to return back 48, 293, and 938, because those correspond to the indexes 2 through 4. Arrays can change size in MATLAB. So here I had an array with only 4 elements, sorry. And I told MATLAB that there's a 6th element and it has a value of 5. And MATLAB will automatically fill in the 5th element here to just a value of 0, and it'll assign this value here to the 6th element. Yeah. Here's some really short examples. I'm going to go through these really fast. If you need a little bit more time, I'd recommend just pausing the video and then watching it, or pausing the video, trying it, and then seeing if you get it right. So number 1, just create an array from -2 to 5 in steps of 3 times 10 to the -2. Number 2, change the 5th element of the following array to a value of 0. Number 3, write a statement to access the circled element in the 2D array A. So that would be element number 98 here. Yeah. 4, write a statement to give the entire last row of A. So you want this entire last row containing the values 92, 55, 98, 15. And 5, write a statement to give the entire last row of a 2D array called array 5. And this array 5 could be any dimensions. Yeah, and here's how I did it. And finally, number 6, use slicing to print the values circled in blue. Okay, here's an example problem on arrays. After entering a very large 2D array A into MATLAB by hand, you realize that several rows have been switched. Specifically, rows 3, 4, and 5 must be swapped with rows 6, 7, and 8. Write code to perform the switch. And it wants you to do this using array slicing and using nested for loops. So here we go. I'm going to show you how I would do it. I'm going to switch over to MATLAB now. And here I just have a document. The only thing I've really done is just define A and then write what we actually want to do up here. Okay. I'd also encourage you to pause the video and just try this on your own. And then if you get stuck or you're confused, you can come back and see how I did it and see the logic behind why I did what I did. So the first thing a lot of people might be tempted to do is you want to swap the rows 3, 4, and 5 with rows 6, 7, and 8. And so something you might want to do right away is just go rows, you can use slicing. Something you might be tempted to do is just redefine rows 3 through 5 as rows 6 through 8 right away. And you can do this, but you're going to have an issue. If I run this, I'll let you do this. Oh, forgot to specify the columns I wanted. Now, if you run this, you're actually going to see you have a little bit of an issue here. So we redefined these 3 rows to be rows 6 through 8, but we run into the error where our array now does not have these original values in it. So one way to get around that would be to assign the values in the rows 3 through 5 to a temporary variable. I'm just going to call that temp. And now that I have that defined, what I can do is I can redefine rows 6 through 8 of array A as temp. And this should successfully swap our rows 3 through 5 and rows 6 through 8. Okay. Oh, I made an error. And if you see here, we have successfully swapped rows 3 through 5 and rows 6 through 8. So you can see using slicing, this problem was pretty simple. Now I'm going to comment out part A. So that way we can go and work on part B. And part B is you want to do the same thing. You just want to use nested for loops. Okay. Okay. Now that we did part A, here I'm going to go over part B. And this is probably going to be significantly more confusing for a lot of you because we're using nested for loops instead of slicing. So when I use for loops and arrays, something I like to do is I simply like to get the size of whatever array I'm working with. Call A an n by m array. And up here we ran into an issue where once we redefined rows 3 through 5 of A, we lost the original, once we redefined rows 3 through 5 of A as rows 6 through 8, we lost the original values of rows 3 through 5. And so that's what that temp variable did for us. Here, instead of writing temp, I'm just going to write a whole matrix B and set that equal to A. So B is just going to contain all the original values of A. The first thing I'm going to do is I'm just going to try to redefine rows 3 through 5. I'm not going to worry about rows 6 through 8 yet. And the way I'm going to do that is using 2 for loops. The first one is going to iterate through the rows of A. And so we want it to iterate through rows 3 through 5. And the second for loop is going to iterate through all the columns of A. And so I'm going to use M, which we defined here to be the number of columns in A, for that second for loop. And I'm going to define my ends right here, so I don't forget. And I wanted to define rows 3 through 5 of A and all the columns. So that should just be A of I comma j. And I want to set that equal to rows 6 through 8. Well, if you think about it, 3, 4, and 5 and 6, 7, and 8. 3 and 6 are separated by 3. 4 and 7 are separated by 3. And 5 and 8 are separated by 3. And I want to redefine row 3 to be row 6. One thing I can do is, as this iterates from 3 through 5, I can take that value and just add 3 to it. And again, we want to loop through all the rows, or all the columns. So let's try running just this, and at the end we will display A. And what this should do is it should just swap our 3 and 5. Go. And as you can see here, we have the original. We have the original matrix A, and then you can see rows 3 through 5 are now the original values of rows 6 through 8. Okay. Now we just have to redefine rows 6 through 8 as the original values of rows 3 through 5. I could create a whole other for loop, but I know the logic is going to be very similar. And so what I'm going to do here is, again, because 6 through 8 and 3 through 5 are only 3 apart, if I do I plus 3, when I loop through the rows of A, the first time these for loops run, I is going to be 1, which would, I is going to be 3, and it's going to access the 6th row of A. Second time, I is going to be 4, and it's going to access the 7th row of A, and so on. And I want to set that equal to rows 3 through 5 of B. And I can do that using that. Okay, and that's pretty much it. That's my code written. And if we run it, we can see that it successfully swaps the rows. Yeah, so that's how I would do that problem. And that's pretty much arrays and indexing it done. Okay. Switching back to how to approach problems. Here are my steps. First, I would identify what you're given and what you know. 2, I would identify your end goal, what you need to find. 3, I would break up the problem into individual pieces. And 4, if you get stuck, write pseudocode. If you don't know what pseudocode is, you can look it up. It's basically just what you want your code to do written in plain English, something that you can understand. The reason pseudocode is so helpful is you write out what you want to do step by step, and then you try to take each of those steps, and then what I try to do is I try to take each of those steps and I write a line of code that's going to accomplish the same thing. And so that way I can take a line of pseudocode and I can turn it into a line of real code. It's not always going to be one-to-one. Sometimes you're going to have one line of pseudocode and it's going to take you multiple lines of code to get that done. But that's how I would approach these problems. So first, we're going to go over problem 11. Again, these problems are from the MATLAB midterm sample problems. And you can find this if you go to modules and then scroll to the bottom of MATLAB lectures. Yep, it should be there for everybody. So problem 11 says, write a function mprod that's going to accept 2 arrays, A and B, of arbitrary size. And it's going to return the product A times B. If the dimensions are not valid, instead return NaN. Okay, so what are we given? We're given a function mprod. We know mprod is going to take 2 arguments and it's going to return 1 variable. And we have arrays A and B. And the things we need to find are whether the dimensions are valid for matrix multiplication. And if they are, multiply A times B. And if they're not valid, then we need to return NaN. So our end goal, one statement, is checking if we can do A times B and then return either A times B or NaN. Here's how I broke that down into some smaller pieces. Make the function, check the validity, calculate A times B, if possible, or return NaN. So I'm going to switch over to MATLAB and sort of work through this problem. Okay, so the first thing is I'm actually going to take the pieces I have, and then I'm going to go through them one by one. First thing I'm going to do is just define a function mprod. Okay. Okay. This is just function definition. If you're confused about this, I would encourage you to look at the lecture notes. Again, we know we're only going to return 1 value, either A times B or NaN. That's why we only have 1 value here. And we know this function wants to take 2 arrays, A and B. All right. The next step is to check the validity. Okay, well, so validity, the way matrix multiplication works is if the columns in A are equal to the number of rows in B, we're good. Okay. Well, I basically just wrote an if statement there, but we don't have the columns of A or the rows in B. We can get those using the size function though. So I'm going to do and these 2 statements are just going to find the rows in A, the columns in A, the rows in B, and the columns in B. Now we want to check if the number of columns in A is equivalent to the number of rows in B. So we can do this using an if statement. So like I wrote here, we're basically going to take that and then write the exact same thing. Okay. Now, if this is true, we want to multiply A times B. If it's not true, we want to return NaN. Okay. Well, we can multiply A times B by just doing. Okay. And we're going to want to return that value. So we'll set that equal to R, because remember, R is the return value of the function. And here we can just do R equals NaN. And that's it. That's our function. It's made. And that's how I would approach that problem. That's how I would break it down and then do it. This problem was very simple. We didn't really have to write pseudocode or anything because it's pretty straightforward. So that's problem 11. Next, we're going to go over problem 12. Here it says, write a function check imag that will take an array of complex values as an input argument and return 2 things. First, an array that contains the complex magnitude of each element, scaled by its index, and 2, a Boolean indicating whether any entries in X possessed an imaginary value of 1. I know that's a lot of words, and it probably sounds pretty confusing. So we're just going to go through our steps right now. right? First thing we're doing, we're given a function check IMAG, and we want to take an array of complex values, and we want to return two variables. First, the new array, and second, a Boolean, a true or false. Things we need to find: one, a new array, and two, whether any entries in X possessed an imaginary value of 1. Breaking this problem down into pieces, these pieces are, again, they're kind of big, but if we get stuck on one of them, we can always break it down into some more pieces or write pseudocode to help us out. I'm going to switch over to MATLAB now, and you guys can see how I would approach this problem. So in pieces, first thing we want to do is define the function. Second thing we want to do is get the new array. Third, we want to figure out whether any entries in X possess an imaginary value of 1. Well, we'll start by defining the function. And we know that this function returns two values. So we'll do R for the return array, and I'll say out for the Boolean. And the function name is going to be check IMAG, and it's only going to take one array of complex values. So I'm just going to call that A. Okay, so that's our first thing done. We've defined the function. Now we need to get the new array. This is probably where a lot of you guys are going to get stuck because the wording here makes it sound really confusing. I am going to actually switch over to a different program, and I'm going to start to write a little bit of pseudocode. Okay, so here we are in this other program. I would highly recommend getting a piece of pen and paper and just writing down what you want each line to do, or breaking down the problem and what you want to achieve with your code. I find it helps me a lot, and I would highly recommend it. It's very useful. Okay, so here we have our problem: a new array containing a complex magnitude of each element of the array, scaled by its index within the array. Okay, complex. So I'm going to break this down into complex magnitude of each element. I want to get that. That's the first thing I want to get. And scaled here just means multiply. So we want to get this, and we're going to want to multiply it by its index. So we're also going to need to get the index. Okay. So how do I get 1? How do I get the complex magnitude of each element? Well, there's a function in MATLAB called norm. So I want to use norm. I want to use norm to get the magnitude of each element. Okay. And 2, to get the index of each element, you should probably use a for loop. Right? When you're working with indexes and arrays, typically you're going to end up using a for loop. So those are the 2 things I want to do here. I want to use norm, and I want to use a for loop. Okay, so now I'm going to write a little bit of pseudocode. This is just the problem broken down into even smaller pieces. I'm going to write a little bit of pseudocode. So for each element in A, get the complex magnitude, multiply it by index, and we want our end goal is to get an array that has all of the elements in A, has the complex magnitude of all the elements in A multiplied by its index. So our end goal is to get an array. And so then our array's name is R. So add value to R. End. Okay. Well, that's a little bit of pseudocode. And now we're going to take this and we're going to implement it in MATLAB. So we're going to do that. So first, I wrote a for loop. So for each element in A, we can write that as for idx from 1 to the length of A, right? And we want to use the function norm. So we're going to do norm of A sub I. Okay, well, that's going to get the complex magnitude of idx. That's going to get the complex magnitude of whatever element of A. So we can say, we can call that mag. All right. Well, that's the first bit done. Now we need to multiply mag by the index we're on. That should be mag times idx. And we also want to take the original array R and put this at the end of that array. So one way to do that would be, or not the original array, sorry. We want to take the return array R and add this to the end of it. As I went over earlier, earlier in this review video, you can do that using this. Okay. Now, if you're looking at this, you might notice that we can actually simplify this down to one line of code. We could take norm here and just put it down in here. That would make it, I guess, a little bit more efficient, but this is just how I would logically think about doing this, right? We're just breaking down the steps here. And next thing we want to do is we want to figure out whether any entries in X possess an imaginary value of 1. Okay, well, I'm going to think of this as a switch. If any of the entries in X possess an imaginary value of 1, it's going to be that I want that switch to turn on. It's going to be true, right? I can find out whether any of these entries possess an imaginary value of 1 using a for loop. Since I already have a for loop defined right here, I'm going to go ahead and use the same one. So if imag of A of I, idx, sorry, equals 1, we want out to be true. Okay. But like I said earlier, if I think of it as a switch, we want it to start in the off position, right? At the beginning, we don't know whether any of the entries in X have an imaginary value of 1. So we're going to assume that none of them do. And as we go through this for loop, if one of them does, out will be changed to true. But at the beginning, we want out equal to false. And that's how I would approach problem number 12. Um, I hope this review was helpful. Uh, if you're still confused on anything or you need help, feel free to message me on Canvas or send me an email, whatever. You can also ask the other TAs or TFs, and of course, Professor DeVoe. Thank you and good luck on your exam.